Picture this. You're standing on the shoreline of one of the world's great coastal cities. You look out, expecting to see the familiar skyline and busy streets, but the landscape is totally unrecognizable. Welcome to This Explainer. Today, we're diving into a pretty monumental thought experiment based on real, rigorous climate science. What if global sea levels rise by 10 meters? We're talking about 10 meters, or roughly 33 feet of extra ocean. This wouldn't just make our beaches a little narrower. We're talking about beaches totally gone, entire neighborhoods underwater, millions displaced. It would permanently drown vast low-lying areas, swallow up huge industrial zones, and require literally one of the largest adaptation efforts in human history. Sounds a bit like a sci-fi disaster movie, right? Part 1, the science and timeline. So let's address the elephant in the room right off the bat. It is super common when we talk about extreme climate scenarios to picture a sudden, catastrophic flood. The big question is, could sea levels suddenly rise 10 meters by the year 2100? Well, thankfully, the answer is a hard, reassuring no. Current scientific projections absolutely do not expect a 10-meter rise by the end of this century. The expected rises for the 21st century are actually substantially smaller. We're exploring credible long-term science here, not sensationalized Hollywood plots. Getting to that 10-meter reality would take centuries, maybe even millennia of sustained warming. But, and this is a huge but, the tipping points that guarantee that future, we are triggering those right now in the 21st century. The pace entirely depends on our future greenhouse gas emissions and how stable our ice sheets remain. The physical effects might unfold in slow motion, but the trigger gets pulled in the blink of an eye in geological time. Now, when you think of rising oceans, your brain probably jumps straight to melting ice. But there's a massive hidden driver here: thermal expansion. The oceans absorb over 90% of the excess heat trapped by greenhouse gases. And because water physically expands as it warms up, this warming seawater simply takes up more space. Even without a single ice cube melting, our warming oceans are literally swelling. But of course, the ice is definitely melting too. To give you a sense of the scale, if the entire Greenland ice sheet melted, global sea levels would rise by about 7 meters. That's staggering all on its own. But wait until you see the numbers for the Antarctic ice sheet. 58 meters. That is the sheer amount of potential sea level rise currently locked up in Antarctica's ice. The West Antarctic ice sheet is especially vulnerable here because huge parts of it actually sit below sea level, which makes it highly susceptible to rapid collapse as the surrounding ocean warms. If those floating ice shelves break apart, the massive land-based glaciers behind them can slide into the ocean even faster. Part 2, cities under the waves. So what does this actually look like for us? Well, the hardest hit areas would be the world's low-lying coastal plains and river deltas. Places like Bangladesh and the Netherlands. We're talking about vital agricultural and economic engines like the Nile Delta, the Mekong Delta, the Mississippi Delta, and the Pearl River Delta. And we absolutely can't forget small island nations. Their situation is incredibly dire because, frankly, they lack higher ground. When the water comes up, they literally have nowhere to go. And it's not just rural deltas that are in trouble. Because of historical trade routes, humanity built its biggest, most prosperous cities right on the water's edge. A 10-meter rise puts massive chunks of these iconic economic hubs at extreme risk. New York, Miami, Shanghai, Mumbai, London, Tokyo, Venice, Jakarta. Now, the exact flooding depends on local elevation, land sinking, and whatever massive seawalls we try to build. But make no mistake, the fundamental geography of human civilization would be totally rewritten. Part 3, the global ripple effect. You see, it doesn't just stop at flooded streets. The ripple effect is a global shock to the system. Take the economy. Something like 80 to 90% of global merchandise trade moves by sea. Flooded ports mean completely shattered international supply chains, not to mention coastal real estate becoming totally uninsurable overnight. Environmentally, protective wetlands and mangroves just disappear if they can't migrate inland. And on the human health front, flooded grids mean waterborne diseases thrive and healthcare access plummets exactly when natural disasters strike. It is a full-on cascading crisis. And actually, the damage isn't just happening on the surface. We have to talk about saltwater intrusion. As sea levels rise, saltwater creeps inland, working its way into rivers and underground aquifers. This basically salts the earth, degrading soil, destroying vital rice-growing regions, and contaminating the very freshwater systems we rely on to drink. Combine that with a growing global population, and you've got a direct, catastrophic threat to global food and water security. So all of this leads to a pretty crucial point. When you flood megacities, choke off global supply chains, and ruin the soil, people have to move. Hundreds of millions of people currently live in these low elevation zones. The permanent relocation of all these populations is going to put unprecedented, unimaginable pressure on inland housing, infrastructure, and international borders. It will undoubtedly be one of the greatest tests of global cooperation we have ever faced.
Part 4. Can humanity adapt?
How do we even begin to survive a shift like this? Well, human response usually happens in escalating steps. Step 1 is brute force engineering, building massive seawalls. But those cost a fortune and need constant upkeep. So Step 2 leans on nature, restoring mangroves and wetlands to act as natural shock absorbers. Step 3 is literal elevation, raising roads, power grids, and homes above the new floodlines. But eventually, in a lot of places, we hit Step 4, managed retreat, just packing up and moving inland. It's a bitter pill to swallow politically, but it's increasingly recognized as an unavoidable reality.
But here's the good news. We aren't just sitting ducks waiting for this to happen. Reducing that future sea level rise depends entirely on limiting global warming right now. The strategies outlined in the science are clear. Transition to renewable energy, electrify our transportation, protect our forests, aggressively cut methane, and scale up carbon capture. Every single fraction of a degree of warming that we avoid today directly reduces the long-term melting of those massive ice sheets.
And that really is the core message of this whole explainer. The scientific evidence is absolutely crystal clear. Sea levels are rising, and they're going to keep rising for centuries. But a 10-meter catastrophic rise, that is not an inevitable locked-in fate just yet. The incredibly slow, creeping timescale of melting ice is directly controlled by the very urgent, fast-paced timescale of the decisions we are making right now.
So I want to leave you with this final thought. We are literally holding the pen that draws the coastlines of the future. How will the energy choices we make today redraw the maps of our world thousands of years from now? The actions we take in this century are going to echo for millennia. Thanks so much for joining me for this explainer, and as always, keep questioning the world around you.